Okay, so here is question number 26. Question number 26 says, suppose that a function f of x is 3 over 8x squared for all real values of x. Explain why f is not a valid probability density function. Part B says to find k so that f of x is in fact a probability density function in the interval 0 to k. And lastly, to find the probability of the function for values of x lying between 0.5 and 1.2. If you need to go back and look at the question, please do so. But otherwise, here is the first part of the question. We want to show, explain why this function here is not a probability density function in the interval that is given there. Okay? Now, this is a quadratic function, so obviously we know that for a function to qualify as a probability density function, it has to be above the x-axis. All right, that means the function has to be positive for the interval indicated, and that for that interval indicated, the area under the graph needs to be equal to exactly 1. So why is this not a probability density function for the given range? So clearly, the graph of f of x is going to be above the x-axis because this is quadratic and it starts from 0. So it's clearly going to be above the x-axis for all values of x. However, over the range that is given, the graph is going to have an area that is infinite. Okay, so we're going. These are still just the condition for the function to qualify as a probability density function. So f of x has to be greater than or equal to 0 for all values of x in the interval that is given. Okay, and then the area under the graph need to be equal to 1. That's what we need to show. All right. So why would this fail to be a probability density function? Since we know the graph is above the x-axis, the only other thing has to be that the area under the graph cannot be 1. And this makes sense even before we do it, because the interval is infinite, and for an infinite interval, the area under the graph is also going to be infinite. Okay, that has to be the reason. Right? So in this case, the domain or the interval x is real, all real numbers, or x starts from negative infinity to infinity, is an unrestricted domain, and so fails the second condition. The second condition being to try and find the area under the graph, which is going to be infinite. It's not going to be 1. All right? So that's the answer to this particular question. The second question is to find the value of k so that f of x is a probability density function in the interval 0 to k. All right, so let's see this. So here is the function. We want to check the interval 0 to k. So because it is a probability density function in the interval 0 to k, we need it to be a probability density function in the interval 0 to k. We are going to find that integral replacing the upper limit with k. All right, so by condition number 2, here is the graph of the function. So by condition, the second condition, we want that the area from 0 to some value k there, which we do not know right now, it's appearing here as 2, but we don't really know it, it's k. We want that area to be equal to exactly 1. Okay, so the integral of the function from 0 to k needs to be equal to 1. If we integrate that, the left-hand side, we get 1 over 8, because this becomes x cubed over 3. The 3 cancels with that 3, and we have 1 over 8x cubed, and put in the intervals there. If we substitute, we get k cubed over 8 equals 1. All right, so k cubed over 8 equals 1, and so k cubed is 8, which is to suggest that k has to be 2. All right, I did that there. So the value of k, in short, is going to be equal to 2. So if k is 2, if this interval here, if we put 2 here, then our function is going to be a probability density function. Hope that is clear. Find the probability that x lies between 0.5 and 1.2. Right, to do that, we know that this is a probability density function, so we want to find the probability that x lies between 0.5 and 1.2. That is equivalent to saying what's the area under this graph, okay? That's shaded area. So to do that, we're going to integrate from 0.5 to 1.2 of our function 3/8x squared. If we do that, you can substitute this directly in a calculator, of course, or we can do this. Substitute in your values of 1.2 and 0.5. If you check that out, the answer is 0.2. That is to 3 significant figures. There are decimals beyond that, but to 3 significant figures, the probability that a value of x lies between 0.5 and 1.2 is going to be 0.2. Okay? I hope you understood that. See you for question number 27, sorry.